Okay, good morning everybody. Oh, what a disaster yesterday was with our Zoom. Hopefully you kids are figuring it out. But anyhow, call me, text me, whatever you guys need to do if you need help, okay? So today's lesson, 1:8:21, okay? So angle of elevation. Before we do anything, angle of elevation, everything starts from what we call the horizon. Sorry. So the horizon would be straight across flat, right? That would be the horizon. And then if you elevate from the horizon, that's the angle of elevation. Okay? So example 1. A 6-foot man sights the angle of elevation to the top of a building to be 64 degrees. If he is 100 feet away, how tall is the building? So let's draw a picture. Right triangle, of course. So here's my building. Okay, here's my building. Here's my man. He's standing way over here, and he's standing 100 feet away. So he sights the building, but he sights it from his eye. Therefore, the triangle we're going to be looking at is going to be suspended by 6 feet. So the triangle we're looking at is this triangle right here. So when I find all of my information, I'm going to have to add in his 6 feet, because the triangle is, in a sense, from his eye, so it's elevated by 6 feet. Okay, so here's my triangle. 64 degrees. We know this side is 100, and we want to find the height of the building. Let's just call it B for building, okay? So, as always, what we do is we start at the angle. Here's my angle. We label our sides. Well, the 100 is right next to the man. That's my adjacent side. And the B of the building is opposite of him, so it's the opposite side. Okay, so opposite, adjacent, it's got to be tangent, right? So I'm going to set up tangent of my angle, or tangent of 64 degrees, because that's theta, my angle, is equal to my opposite, which is B, which was what I want to find out, the building, over my adjacent, which is 100. Okay, so I'm just going to multiply then up the 100, put it right there, multiply up with 100 of 100 times the tangent of 64 degrees. I just use my calculator, right? Okay, what is 100 on 100 tangent 64? I get an answer about 205. So the building is about 205 feet. But don't forget, we're going to add in the height of the 6-foot man. So 211 feet is the height of the building. Okay, awesome, easy, right? Angle of depression. Let's talk about angle of depression. So again, everything starts with the horizon. So here's my horizon. So think about a submarine taking a dive into the water, okay? Here's the water, the horizon, and all of a sudden the angle of depression is that angle, okay? Okay, so, all right, if we take a look at that, then let's take a look at the next example. An airplane 5,000 meters in the air begins a descent to the airport at an angle of depression of 10 degrees. How far is the plane from the airport? Let's draw a picture. Here's my little airplane. Again, Mr. Davies not an artist, but that's okay. It's all good. There's my airplane. Here's my airport way down here. Here's my tower. So the airplane's coming down to the airport, right? So the angle of depression is this angle here. So that's a 5 degrees. Now I can create a right triangle above the tower, and I know that the airplane is 5,000 meters above. So here's my 5,000, right? 5,000. So 5,000, right? So if I want to find out how far it is, then I'm just going to call that distance. It's called D for distance. That's the distance of the airplane. So how far is the plane from the airport? That's the distance. Now we're not talking about the ground distance. We're saying how far is the airplane. Not how far is the ground distance, but how far is the airplane. That's that distance there. Okay, so let's take a look at what we have. So from the angle, right there, then the 5,000 is directly opposite, right? And what I want to find, D, is the hypotenuse, right? Because it's opposite the 90. So I have the opposite. I want to find the hypotenuse. Which one is it? Opposite hypotenuse. It's going to be sine, right? It's going to be sine. So let's set it up. So I'm going to go sine of theta, but theta is my angle, which is 5 degrees, equals my opposite side, which is my 5,000, divided by my hypotenuse, which is D. Now this one's different because when you multiply it by D, you don't really solve for D, but we're going to do this in 2 steps. It's going to take 2 steps. So I multiply up the D, put it there, and I'll have then D sine of 5 degrees equals 5,000. And again, I'm still trying to solve for D. So I'm going to divide by sine of 5 because it's just a number in my calculator. So divide by sine of 5, divide by sine of 5, and I'll just use my calculator. Should be a pretty big answer because I'm a long ways away. So 5,000 divided by sine of 5. And I get an answer of about 57,000, long ways away. 57,368 meters. That's a long ways away. Okay, in terms of how many kilometers, you know, it's like 57 kilometers away. Okay. All right. Next one. Number 3. Okay, find the area and perimeter of an isosceles triangle which has a vertex angle of 40 degrees and a base of 12. So let me draw a picture, okay? It doesn't have to be perfect, but... So if it's isosceles, then these 2 sides are equal, okay? This angle's 40 degrees and the base is 12. Well, okay, I've got a picture, but this is a right triangle trig. Right triangle, so I'm going to try and make this into a right triangle. So the first thing I'm going to do is just break that whole triangle in half, okay? Oh, here's my alarm. Okay. Just remind me to go to school, okay? So then, what I'm going to do is this. Let's first find the height of the triangle. And then that's a 20-degree angle because I just cut it in half. And this side's 6, right? So if I can get the height of the triangle, then that would help, okay? So first of all, opposite, right? Here's my angle. That would be my opposite. And that's my adjacent. Opposite, adjacent, opposite, adjacent. It's going to have to be tangent. So we'll go tangent of theta, but theta is my angle. Theta is 20 degrees, is equal to my opposite, which is 6 over my adjacent, which is h. Okay, same thing. When it's on the bottom like that, I'm going to have to multiply and then divide, right? So let's multiply up the h. We'll have h times the tangent of 20 equals 6, and then we'll divide by tangent of 20, and we'll get an answer of whatever my calculator tells me what is. 6 divided by tangent of 20, and I get an answer of about 16.5. So the height is 16.5. Now if I want the perimeter, then to find x, I think I'll use sine, right? I want to find the perimeter, I'm going to have to find this. So sine would be opposite over hypotenuse, which that is my hypotenuse, right? Because there's my 90. So opposite hypotenuse is sine. So I'll set up sine of 20 degrees is equal to the opposite over the hypotenuse, right? Okay. Opposite hypotenuse, sine of theta. Okay, I got that set up. Again, the variable's on the bottom, so I multiply by the x. I bring it up. I'll have x times the sine of 20 equals 6. And I'll divide by the sine of 20. And I'll use my calculator. What is 6 divided by the sine of 20? I get an answer of about 17.54. Okay. So now perimeter. Well, that's easy. I've got 17.54, 17.54, and I've got 12. So I'm going to go 17.4 plus 17.54 plus my 12, because that's the perimeter, right? Add them all up. And I get an answer of about 47. About 47, we'll say centimeters, okay? Yeah, centimeters. Area is easy, because you know area is 1/2 base times height in a triangle. So the base is 12, and the height is 16.5. Okay, so I'm just going to go ahead and do that. I'm going to go 1/2 times 12 times 16.5, and my calculator gives me an answer about 99. And that'd be centimeters squared. Okay, there's my answers. Let me highlight that, okay? Okay, last but not least, and I'm running out of time because I got another meeting to go to, but here's how it works. Okay, the area. First of all, in this triangle, there are 5, or in this pentagon, there are 5 equal triangles. Okay, what I want to do is look at a right triangle. So I'm going to cut that in half. Okay, so I'm going to really work with just this triangle. So let me draw that triangle really big over here. Okay, here's what I know. This side is 5. Okay, I want to find the area of this triangle. Find the area of that triangle, and then I will multiply that times 5. Okay, so to do that, first of all, let's go here and find the height. So we're going to have to find the height of this triangle. Well, let's go back. What's this angle here? Well, in a circle, there's 360 degrees, right? And I've just cut that into 5 angles. So if I take in 360 and I get each piece of this, divide the angles by 5, I get 72 degrees. So each of these are 72 degrees, 72 degrees, 72, 72, 72. But in this triangle, I just cut that in half. 36 degrees. All right, now here's what I have. I want to find the height. So to find the height, opposite, adjacent, I want to find the height. Opposite, adjacent, opposite, adjacent, opposite, adjacent. Which one is it? It's got to be tangent. So tangent of theta or tangent of 36 is equal to the opposite, which is 5, over the adjacent, which is h. So here's what we've been doing. We know we're going to divide. So let's just skip a step and say that h is equal to 5 divided by the tangent of 36. And I'm just going to use my calculator. Okay, 5 divided by the tangent of 36. Okay, an answer of about 6.88. So the height of this triangle is 6.88. Okay, so now let's go back to the orange triangle. Okay, my orange triangle, which I'll superimpose. has a base of 10 and a height of 6.88. So area is easy. 1/2 base times height, and that'll give me the area of the triangle. But then when I'm done, I'm going to multiply that by 5. Okay, I get an answer of 34.4 for the triangle. Then I'm going to multiply that times 5 because I've got 5 triangles. Okay, times 5, and I get a grand answer of about 172 centimeters squared. Okay, that's what I have for you today. Test on Thursday, last test. Hopefully it'll be successful. Okay, that's all I got.